Welcome back to part 2 of sketching inverse trig functions. We're going to graph the arc cosine. Remember, that's the inverse sine, the arc cosine, and the arc tangent functions right now. They're pretty easy to graph, like I said, And the one thing we're going to take a look at, if you understand about the domain and ranges, you can actually sketch these pretty easily. For example, the arc sine, don't forget, its domain from -1 to 1, and its range from -pi/2 to pi/2. So if we graph that, it's not too bad to do. The domain for, remember, goes from -1 to 1, and the range from -pi/2 to +pi/2. And if you look back on the other page, just get some points. Makes it pretty easy for you. Look at some points. Remember, when in our restricted domain, the sine, it was at -pi/2 to -1, and it was at 1 to pi/2. And I'm just going to take those same points and graph them. Remember, it was -pi/2, -1. So if I switch them, it's going to be -1, -pi/2. And the other point, it was on the original function, was pi/2, 1. So if I flip them, it's going to be 1 pi/2. So right up here. And of course, it does cross with the origin, and we sketch it. Remember the sine curve? When we graphed it, it went down like this, so we're going to go up like so. And there's our inverse sine graph. Very easy to do. Cosine, same idea. The domain from -1 to 1, but the range goes from 0 to pi. Going back over here, the original function, if we remember, it had points. Let's find out. This is the original function. Cosine, it had original points at 0, 1, and pi -1. So it was at 0, 1, and pi -1. If you flip them, this is my function, here's my inverse points, 1, 0, -1, pi. So 1, 0, -1, pi. And it does cross at pi/2. Remember, it's different. The y-axis is going to be our x values from our normal trig function, so 0, pi/2, pi. And if I graph it, remember, cosine went down, like so, so we go down. Like so. There's a graph. Be careful. Sometimes people want to switch them. It's kind of weird, but it kind of almost fixes itself, graphs itself. And there's our cosine curve. Our arc tangent graph, the same way. The nice thing about this one, the domain is positive and negative infinity. So if we graph this one, that is telling us that we have asymptotes. So at pi/2 and at -pi/2, we're going to have our asymptotes. Crosses at 0. Remember, tangent originally goes up. So if this is the function that goes up, our new function is going to go to the side. And like this. I call it the Superman curve, because it looks like an S, like, Superman. Okay, not so funny. I get it. Alright, so those are our graphs. Now, if you look down here, there's some extra little notes for you. There's our inverse. Don't forget, this is my arc sine. Here's my arc cosine, and this is our arc tangent. And down below, there's a few more notes for us. Having restricted the domain, the interval in which the graph is so that each inverse is a function results in only one answer for each problem. That's very important for us tomorrow. This because, remember earlier, if I were to say the sine of x equals 1/2, we would have two answers. Okay, we would have pi/6 and 5pi/6. But what we want to do is we want to make it only have one answer. And that's why we really restrict our domain, so that we only have one answer for each problem. And we're going to take a look at that tomorrow in the next few days. Now, the range of sine and tangent, if you notice, is going to be into the first and fourth quadrant. And that's easy to see up here. My range, 0 to pi/2, that's quadrant 1. -pi/2 to 0, remember, that's quadrant 2. Same thing for tangent. Remember, 0 to pi over 2, that puts us in quadrant 1. And of course, 0 to negative pi over 2 is in quadrant 4. And you can easily verify that looking at the graph here. Take a look. If you look at these functions, take a look. Quadrant 1, quadrant 4. It's just backwards. Quadrant 1, quadrant 4. Now, look at cosine. It's different. Cosine goes from 0 to pi over 2. Well, that's quadrant 1. And from 0 to pi, that's quadrant 2. So cosine, all of our answers are either going to be in quadrant 1 or quadrant 2. Now, what's really neat about this, it's going to take care of one negative, one positive. So if sine is negative or sine is positive. Same thing for tangent. Tangent value is negative, tangent value is positive. Cosine. Tangent's positive, tangent's negative. Okay, so it's going to take cosine positive, cosine negative. So it's going to take care of our answers for us. And then again, we're going to hit that heavy tomorrow and the next few days. Okay, and we did label all that. All right. Now, graphing these, very easy to do. Let's graph number 1 right here. Now we're going to graph the inverse sine. So the first thing I'm going to do is sketch the original function. Remember, sine negative 1 to 1, pi over 2, negative pi over 2. And this is my original function. And I'll kind of graph it in red, I suppose. Dash it. Remember, there's my sine graph. Now, what does that 2 do to us? Remember, this is a period change, right? That changes our period. In other words, this is a horizontal stretch. Okay? That's a horizontal stretch. And what it tells me to do is to take all of my x values. Now remember, we do the opposite, so if it's multiplying, we're going to divide them in half. So, if my x value is at 1, it's now going to be 1/2. And that's what I'm going to graph here. 1/2. Negative 1 becomes negative 1/2. And that moves my points here and here. So my graph, it's compressed. Its domain, instead of being from negative 1 to 1, is negative 1/2 to 1/2. While the range stays the same, negative pi over 2 to positive pi over 2. Very easy to do. Arc cosine minus pi over 2, again, pretty easy to do. Remember, graph the original, negative 1 to 1, 0 to pi. Now, what I'm going to do here, because I have a a vertical shift, right? That's our vertical shift, and it's telling me to go down, wow, can't spell down today, down pi over 2. Sorry about that. So cosine, remember, starts here, crosses here, and ends here. And I'll graph it dashed in red. All we're going to do is take each point, move it down pi over 2. Well, there's pi over 2, and be careful, I'll need this one anyways, negative pi over 2. I move it down half. Down 1/2 pi over 2, down pi over half of pi over 2, down half of pi over 2. And here's our new graph. Its domain, still the same, negative 1 to 1. And the range goes from negative pi over 2 to positive pi over 2. Very easy to do. Alright, let's take a look at the arc sine. Be very careful. Again, this is my arc sine. So if I'm going to graph this, I'll do this one a little bit slower. Graph the original, just like we've always done and have practice. Arc sine, here, here, and here. I'm going to graph the original dot and dashed in red. There's my original. Now, what's happening here? Anybody? Anybody? No answers? Really? Nobody? Okay, I'll tell you. I'm just teasing. This is a phase shift again. That's our phase shift. And it says to go right 1. I knew you all knew that already. Okay, so I'm going to take each point, move it to the right 1. Here, here, And then this one, oops, that's positive 1 by the way, 2. How come I missed? Oop, didn't move that one. There we go. Forgot to move that one. So when I graph it in black, there's our graph. Its new domain, 0 to 2, and that's my daughter. She is having me turn the light on. And so let me pause this for 1 minute. Take a look at one last example, arc cosine. Okay? And then let you guys try these two at home and try to turn these in tomorrow, okay? All right, so arc cosine. Now the first thing we're going to do, we got to notice we got to factor out that 2. It's been a while since we've had to do this. So when I rewrite this one, I'm going to get the inverse cosine, or arc cosine, 2 times x plus 1 minus pi. And I might list out my transformations here. I call them B hack, because go by my wrapper name. The B is telling me to take my x values and multiply them by half, or divide by 2. We always do the opposite. Then it tells me to go left 1 and then down pi. There is no A. Okay, so if I sketch this one, remember this is our arc cosine. Graph your cosine. It goes from 0 to pi. Now I'm going to include negative pi here because of my transformations, and I should include some other numbers here too, right? So my arc cosine, remember what it looks like. Okay, it starts up here, crosses here, and ends here, right? So it looks like so. And then we just do our transformations. Cut it in half. That puts me at half. Be careful. Left 1. Put it down here, and then down pi. I'm on the axis. Okay? Now, the next point, cut in half, already at 0. Left 1, down pi. Puts me at negative pi over 2. So it puts us right here. And this last one, half, left 1, down pi, right over here. And we have our graph. Its domain looks to be at negative 1.5 to 1/2. The range looks to be from negative pi to 0. Alright, so try numbers 5 and 6 and we'll go over these tomorrow. Look forward to it, okay? Not too hard to do. Be careful, arc tangent. That's going to be a horizontal stretch. So be careful with that one. Alright, thank you. Bye-bye.